Good morning, student. Today we will want to discuss about the topic of optimality test of a transportation problem. If you follow the last lecture, after the last lecture, you can recognize that we have just discussed the first step of find the initial basic feasible solution. First one is the northwest corner method. Second one is the matrix minima method. And the last one is Vogel approximation method. After the comparison of all the three methods, we can recognize that Vogel is the best method. That doesn't mean all time Vogel approximation method gets the best get the better solution than the matrix minima method or other. But when we find the initial basic feasible solution, in that case you have to identify is this solution is the optimal, that means the best solution or not. Exactly, that's why we need to test that the solution is optimal or not. If the solution is an optimal solution, then it automatically becomes the optimal solution. What is the meaning of optimal solution? That is very important. Optimal means you can easily recognize that if you are a owner of a company, if you want to buy something from the market, in that case you always try to reduce your costing. Okay, if you want to reduce your costing, the optimal costing means the minimum cost. Okay, and the second one, if you sold your production, in that case your desire should be the maximum profit. Maximum profit means how much you can profit with the competition in the market. So the optimal means if it's a profit problem, you have to identify the best profit. If it's a minimization problem, that means it's a costing problem, you have to find the least cost of the problem. You can utilize all the things. So, first case is to find the initial basic feasible solution. When we find the initial basic feasible solution, then you have to identify this solution is a optimal solution or not. If the solution is an optimal solution, then you can easily say that this solution is the optimal solution. If it is not an optimal solution, in that case you have to modify the solution to become its optimal solution. Okay, exactly, that's why here we use the concept the optimality test. You can find the optimal test in two different method. One is the stepping stone method, another one is the Modi method. This Modi method is also known as the modified distribution method or UV method. Okay, so we move to the optimality test. Before we move to optimality test, we have already mentioned that transportation problem, when we formulate the transportation problem, it's become a linear programming problem. Since it's a linear programming problem, we have already learned that the simplex is the best method to find any linear programming problem. But when we solve a transportation problem, we cannot use the normal simplex table to find the optimal solution, but it's a different approach of the simplex method. But still it's a simplex, but we cannot demark or you cannot draw any table according to the simplex method. Here we use the different approach of the simplex method. Okay, but you have to recognize that when we start a simplex method, we always find the initial basic feasible solution, because when you start your problem you need to a basic feasible solution. The question is that why we need to a basic feasible solution? Because the fundamental theorem of linear programming problem says that every linear programming problem is either feasible or infeasible or unbounded or degenerate and so on. If it has a feasible solution, then it must have a basic feasible solution. If it has an optimal solution, then it should be a basic feasible solution. Okay, so every optimal solution should be a basic feasible solution. Exactly for that reason, we always start any simplex method from a basic feasible solution. After calculation, we just moderate our basic feasible solution and gain the best solution or achieve the best solution, that is the optimality test. Okay, so we move to the optimality test checking, that is the first method, stepping stone method, that is not in your syllabus, but still if you cannot learn the stepping stone method, in that case your question arise in your mind should be when we apply the Modi method, it's a technique to the stepping stone method. When we apply the Modi method, you have some queries related to the Modi method. When you learn the stepping stone method, in that case you haven't any query relating to Modi method, what happened. Okay, exactly, that's why we first learn the stepping stone method. It's the stepping stone method. If you observe the last lecture, you can recognize that the BAM method gives this solution. Okay, give this solution. So we start from the solution we have already found from BAM method. If you forget this, then in that case here we mention another one is this. Okay, so this one is your BAM method. In the first cell, the input is 5 unit, in the 1 cell, and 3 cell is 35, and so on. So we start from this table. Okay, so we start from this table. How the stepping stone is execute, it's very important. How the stepping stone is execute, that is very important. Again we repeat. So if you want to find the optimal solution, in that case these are known as, when we use the BAM method, these are known as the basic feasible solution. The question is why it is called the basic feasible solution. The basic means independent and feasible means it satisfy all the constant. You can easily observe 5 plus 35, that is 40. It should be the first constant which satisfy by this constant. 25, 30 plus 5, 35, 25 plus 25 plus 5, 30, 30, and this one is 30. So the solution satisfy all the constant as well as it's from a basic, because how can I check that a solution is a basic solution or not? It's very important. If it forms a loop, then we can say that it's a basic solution. The question is, what is the meaning of loop? Here we draw a diagram for testing the loop of a problem. This one, this one, this one. You can also observe that we just turn from a cell, occupied cell, where the quantity is occupied. আমরা এমন একটা জায়গা থেকে ঘুরছি যেখানে কিছু কোয়ান্টিটি ইনপুট দেওয়া হয়েছে. And the second one is the line should be horizontal and vertical. Okay, this line is horizontal, this line is vertical, this line is horizontal, and you can turn from a cell which is the occupied cell. Okay, so you can easily observe that when you use the northwest corner method, matrix minima method, or the Vogel approximation method, you cannot construct a loop using this norm. You start from any occupied cell, move and turn from a particular occupied cell, or whatever may be the case, from a occupied cell. If you can achieve to the same procedure with the starting point, then it is called a loop. That is the definition of loop. You can also observe a loop is, this one is a loop. Okay, if it is happen that each one is an occupied cell, each one is an occupied cell, this one is an occupied cell, and this one is an occupied cell, this becomes a loop. You can make a arrow here, you can also make a arrow here, you can also make a arrow here, and this one. Okay, you can construct a loop using this. But if we use these three method. Too many method are in different book, but according to our syllabus we just discussed these three method. We are not interested to check this solution is a basic feasible solution or not, because when we use this method, that is automatically becomes a basic feasible solution. You cannot construct any loop using the occupied cell, and that is the way for testing that this solution is a basic solution or not. Okay, so this solution is a basic solution. It satisfies the feasibility non-negativity condition and all the constants, so it's a basic feasible solution. So when we apply any method, Vogel approximation or northwest or matrix minima method, you need not to check the solution is a basic feasible solution or not, because it is automatically should be a basic feasible solution. Okay, since the boundary of the video is 15 minutes, so we cannot continue the stepping stone method. So we just end this video in this particular situation and start the next video for finding the optimality test. I think you are clear about the basic solution, basic feasible solution according to the concept of transportation problem. So wait for the next lecture. It should be the continuation of this lecture. Uh, how can I find the how can I use the stepping stone method and why we use this step? Okay, wait for the next lecture.